Hello everyone, and welcome to the last lecture in the GUI bonus section of this course, where we discussed widgets. And in the introduction lecture, we discussed various GUIs. It was just a written portion, some notes there for you to review. Go ahead and go back and review those. Make sure you understand the full ecosystem and GUI possibilities you have out there. For instance, if you want to do data dashboards and what we've learned so far about widgets, will make a lot of sense to use. If you want to program 2D games like Tetris, you'll probably want to explore Pygame, Pygame. And if you want to do such things like web development and do GUIs on that end, you may not end up using Python at all in the front end. You'll probably use something like JavaScript, HTML, and CSS, and just have Python running on the back end, handling everything else. Okay. So the widget we're going to be exploring today is a widget that explores the Lorentz system of differential equations. Don't worry too much if you don't understand the differential equations or the calculus we'll be going through. This is mainly just a final lecture to show the possibilities of constructing a full-blown custom widget or GUI interface in the Jupyter notebooks. So the Lorentz system, you can go ahead and check them out on Wikipedia. It's basically just a famous classic set of differential equations. And it's famous because when plotted for certain initial conditions, it usually makes kind of a nice figure 8 or butterfly pattern. So that's what it's famous for. So we're going to try to see if we can kind of get this sort of similar animation here from the Jupyter notebook that we see in Wikipedia. And we'll be using some scientific libraries in Python and some statistical libraries, as well as some just general libraries used a lot in data science. So this is going to serve as a nice introduction to some libraries that you'll use a lot in some other courses, such as the Learning Python for Data Analysis and Visualization course. So I'm just going to walk through what we're going to do here. First, what we need to do is a bunch of imports. So I'm going to go ahead and jump over to the live code where I've actually already copied everything. So I'm just going to walk through what each line does. This matplotlib inline. So matplotlib is a plotting library in Python. And what it allows us to do is just do basic plots in Python. And this specific line, matplotlib inline, is the line that allows you to see matplotlib in a Jupyter notebook. NumPy is a linear algebra library for Python. And SciPy is a scientific computing library for Python, used a lot for statistics. And here we're importing a bunch of other stuff from matplotlib, just particular animations, color map names, 3D axes, and then just general plots. So continuing on, we have the other imports that we've been discussing throughout this section: IPyWidgets, interact and interactive, and then IPython.display, clear output, which will clear the output, display, and HTML. So here what I've done is we have a basic function that goes ahead and solves the Lorentz system of equations and then plots them as basically you change the parameter time. So these three lines right here basically set up a figure to be plotted, adds access to it, states it's a 3D projection, and then this dot axis off basically turns off any 3D representation of axis. So we just get a white background. We set the axis limits with this set of commands, set limits. Here, we're basically computing the time derivative of the Lorentz system. So that just solves, this system of equations up here. And then going back, we just choose a random starting point. We uniformly distribute them from -15 to 15. So here you can see we're using NumPy imported as NP. So that's where NumPy is coming into play. We also use it to solve for the general trajectories. So time and xt. Then we choose a different color for each one. Here I'm calling a color map jet. And then what this does, it basically just plots the lines. So what I'm going to do now is just call this whole function here, solve Lorentz. Click Shift Enter, and you can see we've solved it for this particular set of conditions. I can go ahead and change this angle and maybe make a few less lines. And here you can see there's some less lines. Let's just put in 2. Here we have 2 lines. Let's put in 15 and maybe a larger angle here. Well, let's go just really large so we can see the difference. How about, let's say 65, and we'll put in 20 lines. Here you can see that's quite different. So we're just putting in a bunch of things to the Lorentz equation. And now what I'm going to do is pass it into the interact widget that we've seen earlier. And we also pass in limits. So angle can go from 0 to 360. N can go from 0 to 50. Let's go ahead and make that a little smaller so it doesn't get too crazy. We'll say it goes from 0 to 25. And then we also have 2 other parameters, sigma and rho, which have to do with the inputs here, rho and sigma, which are part of the equation here. Here's rho, here's sigma. So we can go ahead and run this, and interact will basically turn these all into floating point or integer sliders that we can interact with. And I'm going to zoom out so you can see the full picture here. And now I can interact, and it'll update the figure thanks to the widgets. And I need to keep max time to a certain amount. I can increase sigma, decrease the number of lines, and it'll update it as I change it. And I can actually change the viewing angle. So you see here, it's basically just being animated. I'm just turning the animation with this widget. And it's also updating all the arrays you're seeing here. So we can increase sigma, decrease max time, increase max time. That basically just says how long these lines are allowed to run. Increase the number of ends, decrease or increase rho. And you can see how the plot changes. Okay, so I hope this gives you a good idea of the power of widgets, and hopefully you've started to think about if these are useful to you, maybe in a work setting or in a hobby setting, how you would use these widgets on your own. Maybe you have some sort of task that coworkers do every day that you'd like to automate it. You might just make a widget for them to fill stuff out and see the results. You never know. But hopefully you've seen the power of GUIs, at least the ones that are available in Jupyter Notebooks. It takes a long time to learn how to use these widgets really effectively, so take your time when you're learning them. I know I kind of threw a lot of stuff at you, especially with all these libraries that you may not have experienced before. But really, this is just the end of the bonus section, so it's up to you to go ahead and explore what interests you. If web development interests you, go ahead and go with Flask or Django. If you're interested in developing data science skills more, you can check out Learning Python for Data Analysis and Visualization. Really, the whole world is open to you now that you know how to program in Python. You can solve any of your problems, well, at least a lot of your problems that have to do with automation with Python programming. So I really just hope you've enjoyed the course. Good job getting all the way to this point. Congratulations. You should be proud of everything you've learned and have accomplished. And I hope you've enjoyed the journey. All right. Thank you, everyone.